Hello students, so in this video we will continue the exercise 1.4. The next question will be, the fifth question will be, find the intersection of each pair of the sets given in the first example. In the exercise, first problem is given, and in each pair of the sets given in the first example we have to find the intersection of the both the sets, right? So I choose the two examples. So the first one is the set x equals to 1, 3, 5. The set y is equals to 1, 2 and 3. So the solution will be, so first given that set x is 1, 3 and 5 and the set y is given to be 1, 2 and 3. So the intersection of these two sets, the intersection is x intersection y. The intersection of any two sets containing the common elements of both the sets A and B, the element which is present in the set first and in the second set both, the elements which present in both the sets, we will be choosing it as the element of the intersection of those two sets. So let us choose the common elements of the set x and y. One is present in the set x, one is present in the set y. So one is a member of one is the element of the x intersection y. So let us take 3. 3 is a member of x. 3 is also a member of x. So 3 is the member of the x intersection y. Similarly, go for 5. 5 is present in the set x but not present in the set y. Therefore, 1, 3 are the elements of the x intersection y. Second one, what is given? Given that the set A is A, E, I, O, U, the set containing the letters A, E, I, O, U, and the set B contains the letters A, B and C. So let us find the intersection. The intersection is A intersection B. Now let us choose the common elements of both the sets. Let us choose the common elements of both the sets. A is present in both the sets, so therefore A is the member of the A intersection B. E is not present in both the sets, it is present in only set A but not B. I is not present in both the sets. O is not present in both the sets. Lastly, U is not present in both the sets. Therefore, A is the only member of the A intersection B. You can see A is the only common element present in both the sets A and B. This is called as the intersection of the two sets. Intersection of the two sets. Let us solve the next problem. The question is, if A is a given set containing the elements 3, 5, 7, 9, 11 and B contains 7, 9, 11, 13, C contains 11, 13 and 15, D contains 15 and 17, we have to find the A intersection B, we have to find the B intersection C, A intersection C intersection D, A intersection B union C, at the last A intersection B union C. Okay, so let us find one by one. First one is A intersection B. We have to write the common elements of the sets A as well as the B. Let us find the common elements of the sets A and B. 3 is not present in both the sets, so it is not a member of A intersection B. 5 is not present in both the sets. 7 is present in both the sets. 9 is present in both the sets, and 11 is present in both the sets. Therefore, A intersection B will be 7, 9 and 11. 7, 9 and 11. Let us go for second one. B intersection C. To find the intersection of these two sets, the set B 7, 9, 11, 13, set C containing 11, 13, 15. So what are the common elements of the B and C set? 7 is not present in both the sets. 9 is not present in both the sets. 11 is present in both the sets. Therefore, 11 is a member of the B intersection C. Similarly, 13 is present in both the sets. 13 is a member of the B intersection C. Third one is A intersection B union C. A intersection B union C. Let us keep the set A as it is. That is 3, 5, 7, 9, 11. Intersection. Let us find this B union C. What is the union of these two sets? So the union of these two sets containing all the elements of the set B as well as the set C. It means you have to non-repeatedly write all the elements of the set B as well as the set C. So let's write this B union C. 7, 9, 11, 13 and 11 is covered, 13 is already appeared, 15. So 7, 9, 11, 13 and 15 are the union of these two sets B and C. So let us find the intersection of these two sets. What are the common elements of these two sets? This is set A, this is the set B union C. B union C. So 3 is not present in both the sets, 5 is not present in both the sets, 7 is present in both the sets, 9 is present in both the sets, 11 is present in both the sets. So 7, 9, 11 are the common elements of the B union C and the set A. B union C and the set A. Let's go for the fifth one, the fourth one. A intersection, that is this one. We did this fourth one. We did this fourth one. So let's solve this third one. Third one. What is third one given is A intersection C intersection D. Let us write the elements of A, C and D. So what is the set A? Set A is 3, 5, 7, 9, 11 and intersection. C set is 11, 13 and 15. Similarly, intersection D set is 15 and 17. 15 and 17. Let us find the common elements in all of these three sets. If a set B is present in all these three sets, then it must be an element of the A intersection C intersection D. Okay. So let's see what are the common elements present in all these three sets. 3 present in this set, not present in this set, not present in this set. Leave it. 5 present in this set, not present in this set, is not absent in this set. 7 is not possible. 9 is not possible. 11 is also not possible. It means there is no element in the A intersection C intersection D. A intersection C intersection D. So this is basically a null set 5, an empty set 5. Let's go for the fifth one. What is the fifth one given? A intersection B union B intersection C. So let us find the intersection, common elements of A intersection B. Already we have found the A intersection B. Let's use this set. So 7, 9, 11 are the elements of the A intersection B. B intersection C also we did here. B intersection C also we did here. In union as it is. So B intersection C is 11 and 13. So let us find the union of these two sets. Let us find the union. What do you mean by union? Union means adding all the elements of these two sets, combining all the elements of these two sets. Condition that it should not repeat again and again. If the numbers are repeated again and again, you have to choose only once. So let us add all the elements. So what are the elements? 7, 9, 11 are the compulsory elements of the set A and will be added with 11 is already there. So 13 will be added in this set. So 7, 9, 11, 13. A intersection B is this set. Union B intersection C is this set. So union of these two sets is 7, 9, 11 and 13. Note on this. And remaining columns you can work out in the home. Okay students, so let's go. Seventh example will be a homework for you, because in the seventh column the same intersection of the sets has to be done. Therefore you can work out in the home similar columns. Let's go for the 8th question. Which of the following pair of sets are disjoint? What do you mean by disjoint sets? Disjoint sets. Okay, so what do you mean by disjoint sets? Disjoint sets set means if A intersection B is a null set phi, if A intersection B is a null set phi, then A and B are disjoint sets. Okay, so if A intersection B is a null set, that is what I mean to say is, if the intersection of the two sets is null set, if the intersection of the two sets is null set, then those two sets are called as disjoint sets. In another words, I can also say that if there are no common elements present in any of the two sets given, then those two sets are said to be disjoint sets. In general, there are no common element exist in the given two sets. Such sets are called as the disjoint sets. Disjoint sets. So let us find Let us find the disjoint. Let us check whether these two sets are disjoint sets or not. So in the first solution, what is given to us? Let A equals to, we will take 1, 2, 3, 4 and let the set B equals to the set which contains x such that x is a natural number and 4 is less than or equals to x is less than or equals to 6. It means the 4 and 6 are the members of the x, including all the numbers between the 4 and 6. 4 and 6 are the members of the set, including all other numbers which are natural numbers between the 4 and 6, that is 4, 5 and 6. So let us find the intersection of these two sets. The intersection of these two sets is A intersection B is equals to, what are the common elements of these two sets? 1 is not a common element, 2 is not a common element, 3 is not a common element, 4 is a common element. 4 is a common element, not even 5 and 6 are the common element. Therefore, what we find? We find that, we note that A intersection B is not a null set. A intersection B is not a null set. Therefore, the given, therefore A and B are not disjoint. A and B are not disjoint sets. Let us go for the second example. The solution for this is, so the set, let us consider this as the set A. Set A contains A, E, I, O, I and U, and let us find the elements. Let us take the elements of second set as a B. Set B equals to C, D, E and F. So let us find the common elements. Let us find the intersection. So A intersection B is equals to, what are the common elements in these two sets? You can think, please. A is not a common element. E is a common element. You can see E and E. E is present in both the sets. E is a common element. I is not present in both the sets. O is not present in both the sets. U is not present in both the sets. Therefore, clearly, what we find? We find clearly that A intersection B is not a null set. Therefore, A and B are not a disjoint sets. They are not disjoint sets. One more example is given in the textbook. Please, you can work out. Note on this. Okay, students. So the next question will be, the 4 sets are given here. There are some elements written in the sets. There are 4 sets given, set A, set B, set C, set D. We have to find the subtraction of these two sets. Set A minus B, set A minus C, A minus D and D minus C. We know the definition that the set A minus B contains the only elements of the set A but not B. Let's recall this definition. Right? Let's please recall this definition, that the set A minus B contains only the elements of the set A but not B. It means if the same element of the A, if some element of the A is present in the set B, then it should not be an element of the A minus B. The only elements which are there in A but not in B are nothing but the elements of the A minus B. So let's do that. Solution. First one. So A minus B. Let us choose the elements of the set A which are only present in the set A but not in the set B. The elements which only present in the set A but not in B, we must choose, right? So let us see what are the such elements. You can see that 3 is present in the set A but not in B. So 3 is the element of the A. 6 is the element of the A but not B. 6 is the element of A minus B. 9 is the element of A but not B. 9 is the element of A minus B. 12 is the element of both the sets, therefore it is not an element of A minus B. 15 is element of A but not B. 15 is the element of A minus B. 18 is the element of A but not B. 18 is the element of A. 21 is the element of A but not B. 21 is no doubt element of the A minus B. Element of the A minus B. Okay. So second one, A minus C. So let's find A minus C. Let's find the elements of the A which are there in A but not in the set B. The elements which present in only the set A but not in B. In C, we have to choose such elements. So let's go. So A and C. 3 is present in the set A but not the set C. 6 is present in both the sets, so it is not a member of A minus C. 9 is present in only A, therefore it is a member of A minus C. 12 is present in both the sets, leave it. 15 is present only in the set A, therefore it is a member of A minus C. 18 is a member of A minus C. 21 is a member of A minus C. You can observe that these elements are present only in the first set C. You can see 3, 9, 15, 18 and 21 are only present in A but not C. You can observe here that there is no 3, 9, 15, 18 and 21 element in the set C. In the set C. So likewise, you have to find rest of the problems. And so let me help for these two, and remaining problems you can work out in the home. Third one, A minus D. A minus D. So let's choose the set A with the set D. 3 present in only in the set A, so 3 is a member of A minus D. 6 present in only set A, 9 only it is present in A, 12 is only present in the set A, 15 is present in both the sets, leave it. 18 is present only in the set A, 21 is present only in the set A, therefore you can see that this is A minus D. These are the elements which are only present in the first set A but not in the second set D. So remaining problems will be your homework. Rest of the problems you can now be able to do in your homes. Please note on this. Okay students, so there are 2 more problems are there. You can please work it out in the home because there are similar problems in the exercise. Okay, so let's go to the next concept. The next concept will be the complement of a set. Complement of a set. So basically, we already have a knowledge of the subtraction of 2 sets, A minus B or B minus C or A minus D, in the last exercise we have did. So based on the same concept, let me define the complement of a set. Okay. So consider that let U be the universal set. U be the universal set and let A be the subset of U. Let U be the universal set and A be the subset of the set U. Then the complement of the set A, the complement of the set A, the complement of the set A is, the complement of the set A is the elements, the complement of the set A is nothing but the elements which belongs to, the universal set but not E. Note on this statement, the elements which are belongs to the set U or universal set but not A. It means what? Basic. So generally how we will write? So generally the complement set of the set A can be written as A complement and will be written as the universal set minus A. The universal set minus A. So these, the definition and the symbolical term both are same. You can see the elements which are belongs to the universal set but not A. It means the elements of the set A are deleted from the universal set. The elements of the set A are deleted from the universal set, or I can say that the deleted set A in the universal set is the complement of a set. You can see A dash, here A dash is called A complement. Here A dash is called the A complement. Okay, you can observe that here A dash is called the A complement. So the complement set A dash is U minus A, is U minus A. Please note down this. This is extremely important definition. Okay students, so there are some properties exist on the complement of the two sets. First one is A union A complement. Let us recall the definition of complement of a set. If U is a universal set and A is some subset of the U, then the complement set of the A is nothing but the elements which are belongs to the universal set but not the given set A is called complement of a set. And I told you that the complement of a set A complement is given by U minus A. U minus A is the complement set. The deleted elements of the A in the universal set is a complement of a set A. So some properties exist here. A union A complement is a universal set. You can see basically the elements, all the elements of the A which are there in the set A, and all the elements of the A, all the elements of the universal set but not belongs to the deleted elements of the A in the universal set. They both, if you take a union, you will get the universal set. You will get the universal set. Second one, the intersection of A and A complement. As A contains some elements, A complement contains elements of the set, universal set, but not A. Therefore, if you take an intersection of these two, you are going to get nothing here, because the already set A, the elements of the set A are deleted in the universal set, and there are no common elements in the set A and A complement. Therefore, you get the null set, empty set, or void set phi. Okay. Third one is A union B whole complement. The complement set of the union of two sets is always equals to intersection of complements of the individual sets. I repeat, the complement of union of the two sets is always equals to intersection of the complement of the individual sets, or both the sets, I can say. Similarly, in terms of intersection, the complement of the intersection of these two sets, A intersection B, is always equals to union of the individual complements of the sets, or complement of both the sets. A complement whole complement. A complement contains the elements of the universal set but not A. If you take that set complement, you are going to get the given set A itself. You are going to get the elements, all the elements of the set A itself. At the end is very important properties are phi complement is universal set. Phi complemented is universal set, because phi is a set which contains no elements, and if you delete these no elements from the universal set, no doubt there are no elements deleted from the universal set. So what is the result? The result is universal set. Similarly, the universal set complement, if you delete all the elements of the universal set from the universal set, what you are going to get? You are going to get an empty set. Therefore, phi is the U complement. The complement of the universal set is phi. The complement of the phi set is universal set. You can note down these properties upon the complement of the sets. They are extremely useful for the upcoming solving the problems. Note down these. Okay children, so let us solve the exercise 1.4. There are some solved examples given in the inserted textbook. Please, you can solve those problems. The solutions are already given there. It will be helpful to solve those problems. Let's go to the unsolved columns in the exercise. So exercise 1.5, the first question is, the universal set is given 1, 2, 3, 4, 5, 6, 7, 8, 9. A set A is defined 1, 2, 3, 4. Set B contains 2, 4, 6, 8, and the set C contains 3, 4, 5, 6. Then ask him to find the complement of the set A complement, second one B complement, third one A union C complement, and the fourth one is A union B complement. So let's solve this. Let A complement is U minus A. U minus A. So what are the elements of the U? The elements of the universal set are 1, 2, 3, 4, 5, 6, 7, 8, 9, and the elements of the set A are 1, 2, 3, and 4. So let us find the solution for this. So what are the elements which are the set A has to be subtracted from the set U. So 1 is there in both the sets, leave it. 2 is there in both the sets, leave it. 3 is there in both the sets, leave it. 4 is there in both the sets, leave it. 5 is not there. 6 is not there, 7, 8 and 9 are not there in the set A. Therefore, you can observe that the definition you can observe that only the elements of the U but not A. You can see that 1, 2, 3, 4 are absent in the U minus A, the complement A. Therefore, this is the complement of the set A. This is the complement of the set A. Second one, B complement. The complement set B has to be written like U minus B. U minus B, because we know the definition, A complement equals to U minus A, B complement is definitely U minus B, C complement is definitely U minus C, right? So U universal set minus the set B, universal set elements are 1, 2, 3, 4, 5, 6, 7, 8 and 9. The elements of the set B are 2, 4, 6 and 8. So let us find the universal set minus the elements of the set B. So 1 is not present in the set B, so 1 is the element of the U minus B. 2 is present, 3 is not present, 4 is present, 5 is not present, 6 is present, 7 is not present in the second set, and as it is, the 9 is also not present. The 9 is also not present. Therefore 1, 3, 5, 7, 9 are the elements of the U minus B, that is complement set B complement. So let's do the third one. So let's find A union C first. What are the elements which are union of the A and C? Let's union the elements of A and C. The set A is here, the set C is here. So let's write combining all the elements of A and C will give us A union C. So what are the A union C? The elements of A union C are 1, 2, 3, 4 and continually 5 and 6. Now A union C complement will be, yes, A union C complement will be universal set minus A union C. Universal set minus A union C. So what are the universal set elements? The universal set elements are 1, 2, 3, 4, 5, 6, 7, 8 and 9 minus what are the elements of A union C is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5 and 6. So let us delete these elements from this and write the elements of the U which are not present in the second set A union C. So 1 is there, 2 is there, 3, 4, 5, 6 is there, 7 is not present in the second set, therefore 7 is a member of U minus A union C. 8 and 9 are the 7, 8, 9 are the complement set of A union C. So similarly we can solve the rest of the problems. Okay. Okay students, so let's solve the next problem. By taking the set of all natural numbers as universal set, choose the natural numbers as universal set, find the complements of the given sets. The first one, you can see the first one is the set builder form of the given set. He has given the set builder form. So set of all x such that x is an even natural number. Okay, so let first one, what is given is the set of all even natural numbers. Even natural numbers are 2, 4, 6, 8, 10 and so on. And we have to find the complement set of this by taking universal set, and let universal set be 1, 2, 3, 4 and so on. So all the natural numbers will be elements of the universal set. So let us find A complement. So A complement is U minus A. You can observe that if you remove all the 2, 4, 6, 8, 10 from the universal set, that is you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and so on, and the set A is 2, 4, 6, 8, 10 and so on, you can see, and so on. What is the set left? So the elements 1 left in the complement of the set A, 2 is deleted, 3 left, 4 is deleted, 5 left, 6 is deleted, 7 left, 9, 11, 13, 15 and so on. Now if you observe these elements, what are these elements? These are nothing but the set of all x's, that x is an odd natural number. So What is the given form? The given form of the question is in the set builder form. Therefore, answer has to be represented in the set builder form. So, in general, what is the given set? So, x is an even natural number. You can see 2, 4, 6, 7, 10, dash up to infinity. There are even natural numbers. And if you delete all these, what left? They are the odd natural numbers. Therefore, x is an odd natural number. This is the solution for the first one. Similarly, you can go for second one. So, this set containing x such that x is odd natural numbers. So, what is the second set B complement? B complement is u minus b. So, u is 1, 2, 3, 4 dash and B set is the order of the odd natural numbers. Odd natural numbers are 1, 3, 5, 7, 9 and so on. Now, if you delete 1, 3, 5, 7, 9 from this set, what left is 2, 4, 6, 8, 10 dash. This is nothing but the set of all x such that x is an even natural numbers. X is then even natural numbers is your answer. Okay, if you delete the 1, 3, 5, 7, 9 odd natural numbers from the set of all natural numbers, what is left is even natural numbers. Even natural numbers. Similarly, you can see the third one. That for third one, as the u is the universal set, the third one is given to be. So, what are the elements of this set? X we have to write. So, the third one is, let it be a set C. So, x plus 5 equals to 8, standing x equals to 3. It means only the element 3 is there in this set. Only the element 3 is there in the set C. Therefore, what is the C complement? C complement is universal set minus the set C. What is universal set? Universal set containing set of all natural numbers 1, 2, 3, 4, 5 up to dash minus the set C contains 3. It means the resultant set contains only all the numbers except the 3. It means how to write this? So, the set of all x such that x is a natural number, but x is not equals to 3. This is your answer. So, x is not equals to 3. This is your answer. Note on this. Okay, note on that. So, as the 3 will be removed or deleted from this universal set, so this set contains all the natural numbers but not 3. Therefore, set of all x says that x is a natural number but not 3. Or I can say and x is not equal to 3. X is not equal to 3. And there are some more examples given here. You can work out in the home. Okay, students. So, the next fourth will be an assignment or homework for you. You can work out in the home. It's a similar problem like to the third question. The fourth question is, draw the appropriate Venn diagrams for. The first one is A union B whole complement, A complement intersection B complement, A intersection B whole complement and A complement union B complement. Okay. So, let us try to draw. So, these are the 4 figures, 4 Venn diagrams I drawn. We just need to find the area. Which area is the first one? A union B whole trans, that is whole A union B complement. You can see that A union B is the complete area of these 2 circles, which are the sets, representation of the sets A and B. So, A union B is totally these 2 circles, the area, this and this area. But we have to find the rest of the area apart from this area. It means the area which is other than A and B. The area which is other than A and B. Look at this. So, I am talking about this area. This area I can say, this area I can say A union B whole complement. Okay, A union B whole complement. You can see here that this area is completely A union B whole complement. You can see that this area, this is the set A and this is the set B, and there are 3 areas. There are 3 areas available to shade. That is, one is area A, one is area of the set B, and one is the universal set. You can see that A union B is this complete space unfilled area, but the complement set of this complete area is the outside the universal set area. So this is A union B whole complement. Let's come to the second one. So what is A complement intersection B complement? What is A complement? The area which is accept the A. What is B complement? The area which is accept the B. And what is the intersection? The intersection means, so this is the area, we have to leave. We have to leave the area which is A intersection means except A, we have to shade all the rest of the part. Intersection of the, that is the B complement, the area of the B except B, area of rest of the part. And what is the common in this? What is the common in this is this area. This area is common. This area is common, you can see. Okay. Okay, students, you can see here that A complement and B complement. A complement is the area which is accept the A. B complement is the area accept B. And what is the common area in this? So this is accept this completely. This shaded portion is completely the area which is common A complement intersection B complement. You can see that this is the area, I can say A complement intersection B complement. You can see this area is A complement intersection B complement. So this complete shaded area, I can refer it to be A complement intersection B complement. So this complete area, this complete shaded area, I can say this area is A union B whole complement, and this area I can say A complement intersection B complement. Whereas the circle 1 represents the set A, circle 2 represents the set B, and the space represents the universal set. The rectangle represents the universal set. Let's come to the third. To draw, how to draw the third Venn diagram. A intersection B. What is the A intersection B area? What is the common area? This is the A intersection B. This is the A intersection B. And we leaving this rest of the area, leaving this area, rest of the area is the A intersection B whole complement. It means we have to shade the rest of the area like this, but that is just except this area. You can see here that except this area, the rest of the area is okay, you can see that this is the area, this is the universal set, this is the set A, this is the set B, and this complete area, shaded area, I can say this as A intersection B whole complement, A intersection B whole complement. So let's come back, let's go to this one, fourth one. So what is complement union B complement? A complement is the area except A, B complement is the area except B, and the union of those two. So what do you mean by this? So again the same picture is going to repeat. I am going to repeat the same picture again, that except this area, the rest of the area, you can see here the rest of the area this completely rest of the area is you can see this area, I can say this area is completely A complement union B complement, whereas the circle 1 represents set A, circle 2 represents set B, and this rectangle represents the universal set U. Therefore, you can observe here that A union B complement, the complement of the union of two sets is this area, shaded area. The A complement intersection B complement is this shaded area, you can see this shaded area. A intersection B whole complement is this shaded area. Similarly, A complement union B complement is the respectively the last shaded area. Note of this.